Okay, so let's go back to our notes. Let's go back to that page we started off with. Now we've kind of combination reviewed, shake off some of that rust, or maybe introduce you to a few new things about a quadrilateral. Let's go back to our notes. So let me find here where our notes are, because now we want to classify. This is essentially what this lesson is all about, is classifying the quadrilaterals based off of just knowing the coordinates. So our number 2 here, we have this quadrilateral off to the right. We want to classify it. Now, just by looks, which we don't always want to do because looks can be deceiving, it looks like it might be a parallelogram. And the way to prove it's, say, a parallelogram is to look at slopes and lengths, okay? Slopes and lengths will determine that for us. So what we want to do then here today is do a lot of slopes, a lot of distance formula, okay? So let's do part A right here. Sorry. Let's find my lengths of A, B, B, C, C, D, D, A. Okay, you can go about using your distance formula. You would have to go through and identify A is located where? At -1, 4. And B is located at where? 2, 3. And then go through and use your distance formula. x2 minus x1 squared plus y2 minus y1 squared, and take the square root of that. Okay, that's our distance formula. You can definitely do that. Because we have it on a coordinate grid, you could also use your Pythagorean theorem. We talked about Pythagorean theorem helps kind of create the distance formula. So what you could also do then is, to find the length of A to B, is create a little quick right triangle. Find the horizontal and vertical leg. So from A to B up here, 1, 2, 3, that's a leg of 3, that's a leg of 1. Whatever you want to do, it's fine. I usually kind of revert to doing this in my head by doing a little right triangle like I did. But you can also just plow through using the distance formula. I don't care. Just make sure you're great at finding lengths, okay? So on that one, the length of AB, 3 squared plus 1 squared, I get the square root of 10. Now again, distance formula is old stuff. We've done that for quite a few lessons now. So I'm going to kind of let you work through that. Pause it here, find those, and then once you find those other three lengths, let's pick it back up. So BC, well heck, BC is just a vertical line. I don't even need to use the distance formula, okay? So what I could also just see is, heck, from B to C, it's 1, 2, 3, 4, 5. It's a length of 5. Then repeat that for CD. 1, 2, 3, 1, square root of 10. AD, 1, 2, 3, 4, 5. It's a length of 5. Now, at this point, we can start to narrow down possibly what type of shape we have. We know we have a parallelogram that has 2 pairs of congruent sides. A rectangle is like that. Square is not, rhombus is not. I guess technically a kite could have that as a possibility, but because we do have the shape kind of here, and we found some of those lengths starting to happen of 5, 5, and the square root of 10, we can tell that the adjacent sides are not congruent. So we're down to probably either parallelogram or a rectangle. And what finishes off and tells me the difference between a parallelogram and a rectangle is all about the slope. So when I go back to my organizer real quick, we know in a rectangle, the adjacent sides are perpendicular. So we want to basically determine, is that the case here? So we first want to go through and let's find some slopes, okay? Let's go through and find the slope of AB. Now we're on the coordinate grid, rise over run, using that 3 and 1 that we found a couple minutes ago. Okay, and I notice it's decreasing, it's going down, so the slope is negative. Rise over run, the slope is negative 1/3. Okay, this is again 6th grade stuff, people. So negative 1/3. Now after that, okay, let's go find BC. It is vertical. Okay, back up here, this is why we reviewed slope. Vertical lines are all undefined slope. CD, left to right, is going down. We found that to be 1. We found that to be 3. It's a negative 1/3. And AD is vertical again. That slope is undefined. Okay, so here's what we've got. Let's try to break this down then. If this was truly, say, a right angle, here this would make a rectangle, but we do not have a right angle. Now the question is, besides just looking at it, how do I know it's not a vertical, how do I know it's not a right angle? All right, this all goes back to then, what do you guys remember about slopes and this idea of opposite reciprocals and this idea of slopes being the same, okay? All right, opposite reciprocals. I'm gonna pause, I'm gonna throw in a sticky here so we can really quick do some review of, again, stuff that probably would have happened in about 8th grade, okay, is talking about some slopes, okay? So let's see if that truly, if you talked about this in 8th grade or not. I'm gonna approach it as if it's not, let's say, brand new for you, but if it is a new thing for you, that's okay, let's talk about it right now. Slopes, sorry. Slopes that are opposite reciprocals are perpendicular. Now, what do I mean by opposite reciprocal? Sorry, that is not clear. Perpendicular. Perpendicular. Let's take like 3/2. Opposite reciprocal. Opposite means change the sign. Reciprocal, sorry, change the sign. Reciprocal means then to flip it. These are opposite reciprocals. 1/5 and -5 are opposite reciprocals. -2/7 and 7/2 are opposite reciprocals. And the only way that happens is if those lines are intersecting at a right angle. Because we have -1/3 and undefined as adjacents to one another, so what I mean by that is this was -1/3 and this was, say, undefined. Those are not opposite reciprocals of one another, okay? It's not -1/3 and +3. What that tells me then is those are not right angles. They're intersecting, just not at a right angle. So the shape is not a right angle because the adjacent, I don't know if I can spell the word adjacent, I think I was right, AD, adjacent sides are not perpendicular. Okay. The shape, therefore, is not a rectangle, it is a parallelogram. Parallelogram, the sides just intersect, the adjacent sides just intersect, just not at a right angle, okay? Now, we'll talk more about some slopes throughout this lesson. If you've never heard of that before, bear with me. That's usually the case I'm finding for a lot of students over the last couple of years coming into geometry, is that you haven't really talked much more about slopes. But if you had heard that, great. You've also might have heard opposite reciprocals referred to as negative reciprocals. It's the same thing, just change the sign and then flip it. Now, we can find the perimeter. Perimeter and area is nice. It reinforces what we've been doing with radical work and also what we've done with perimeter and area. Perimeter, add up the sides. 5 plus 5 plus root 10 plus root 10. Add up like terms. 10 plus 2 root 20. Sorry, I made this simple mistake. I wrote it right. 10 plus 2 root 10 units. Root 10 add together to give you 2 of those, so we say 2 root 10 then. Area. Okay, area for this one's a little funky. It is a parallelogram, and we talked about in the last lesson, the area of a parallelogram is found by taking the area, taking the base times the height. Now, base times height for a parallelogram, it needs to be perpendicular to one another. And in this instance, I'm going to go with that side length of 5. That's nice and vertical. And if you're vertical, that's the way, again, reason why I said that is if you're vertical, to be perpendicular to that, well, you're going to be horizontal. What is that length? 1, 2, 3. that's a length of 3. So that parallelogram we found in the last lesson, base times height, parallelogram, the base and the height need to be perpendicular to one another. Do not take 5 times root 10. We just showed a few minutes ago 5, this length that's 5, the side that's 5, and the side that has a length of square root of 10 are not perpendicular. So I can't do that. But because of this parallelogram, I can just do 5 times 3. That's where that 3 is coming from, because it's perpendicular with that 5 side to the other 5. And the area then is 15 square units. Okay, first one down. And if you're feeling so-so on that, I understand. Give us some time.